Scientists are closely watching a recently discovered asteroid that is being called a potential city killer.
On December 22nd, 2032, Earth might face a visitor from space, Asteroid 2024 YR4. NASA's early warnings sparked fear, with countries like India and Colombia bracing for a possible hit. Was this a real threat, or just cosmic hype? As of March 1st, 2025, the odds have shifted, but the story's far from over. This tiny rock's journey has big lessons about discovery, danger, and how we dodge disaster. The discovery of 2024 YR4. Picture this. It's December 27th, 2024, and the night sky over Rio Hurtado, Chile, is buzzing with more than just stars. A telescope called ATLAS, short for Asteroid Terrestrial Impact Last Alert System, locks onto something new. This isn't your average stargazing tool. It's a NASA-funded beast run by the University of Hawaii's Institute for Astronomy, designed to spot space rocks that get too cozy with Earth. That night, it finds 2024 YR4, a near-Earth asteroid that's about to make headlines. This wasn't a fluke. Atlas scans the sky relentlessly, catching faint glimmers of light that might signal trouble. When it tagged 2024 YR4, scientists got to work fast. They tracked its path, measured its brightness, and started crunching numbers. Early estimates pegged it between 40 and 90 meters wide. Small compared to the monster that wiped out the dinosaurs, but big enough to ruin someone's day. Its albedo, or reflectivity, clocked in at 0.154, suggesting it's a rocky type, maybe silicate-rich, like many asteroids zipping near us. The discovery kicked off a global effort. NASA's Center for Near-Earth Object Studies, CNEOS, jumped in, alongside the European Space Agency, ESA, and others. Within days, observatories worldwide pointed their lenses at this newcomer. Why the fuss? Because its orbit hinted it might swing close to Earth someday, specifically December 22nd, 2032. That date stuck, and soon people were asking, could this thing actually hit us? What's wild is how fast it spins, once every 19.5 minutes. That's like a cosmic top twirling through space, a clue to its makeup and past. Maybe it got chipped off a bigger rock or survived some ancient collision. Either way, 2024 YR4 wasn't just another dot in the sky. It was a puzzle, and scientists were hooked. So how do you go from a speck of light to a potential threat? That's where the next part comes in. Understanding what this asteroid's really made of keeps us one step ahead. But knowing where it came from isn't enough. What's this thing actually like up close? Let's dig into its quirks and figure out why it's got scientists buzzing. What makes this rock tick? So, meet 2024 YR4, a chunk of space debris that's got more character than you'd expect. Size-wise, it's tricky to pin down exactly, but NASA's best guess as of now is about 55 meters across. That's based on its albedo, 0.154 if you're keeping score, which tells us how much sunlight it bounces back. Picture a rock roughly the length of half a football field, tumbling through the void. It could be as small as 40 meters or stretch to 90, depending on how reflective its surface really is. Either way, it's no pebble. What's it made of? Scientists think it's likely an S-type asteroid, silicate-rich, rocky, and pretty common among near-Earth objects. Or maybe it's an L-type or K-type, which are similar but have their own flavors of minerals. They won't know for sure until the James Webb Space Telescope takes a peek in March 2025. But for now, it's a solid bet. It's not some exotic ice ball. This is your classic rocky asteroid. Tough, dense, and built to last. Then, there's that spin. Every 19.5 minutes, it does a full turn. Super fast for something its size. Imagine a boulder flipping end over end as it hurtles along at 12 to 15 kilometers per second. That speed and rotation hint at its history. Maybe it's a fragment from a bigger collision, or it's been shaped by eons of cosmic chaos. It's not just sitting still out there, it's alive in its own weird way. Its orbit's the real kicker, though. Classified as a near-Earth asteroid, NEA, 2024 YR4 swings close enough to our planet to raise eyebrows, but it's not quite a potentially hazardous object, PHO. Why? Its size and path don't fully check those boxes, yet. Early data showed it crossing Earth's neighborhood, with that December 22nd, 2032 date popping up as a maybe moment. Could it sneak past us? Or is it aiming for a bullseye? Here's the thing. Asteroids like this aren't rare. Thousands zip by Earth every year, most too small to notice. But 2024 YR4's combo of size, speed, and orbit made it stand out. It's not the biggest threat we've tracked. Think of monsters like Apophis, but it's got enough punch to keep us watching. Ever wonder what happens when something this feisty gets too close? That's where the risk numbers come in. And trust me, they've been a wild ride. Now that we've got a handle on what 2024 YR4 is, you're probably wondering, how worried should we be? Let's unpack the odds and see how this risk went from uh-oh to phew in just weeks. The risk roller coaster. Okay, let's talk about the part that got everyone's pulse racing. The chance 2024 YR4 might actually smack into Earth. When it was first spotted in December 2024, the data was fuzzy. Scientists had a rough orbit, but not much else. By January 2025, they'd crunched enough numbers to flag December 22nd, 2032 as a possible impact date. The initial odds? A 1.2% chance of collision. That's not huge, but it's not zero either. Imagine rolling a 100-sided die and hoping it doesn't land on boom. Things got spicier in February. On the 18th, new observations bumped the probability to 3.1%. For context, that's like a 1 in 32 shot. Still long odds, but enough to make NASA sit up straight. The Center for Near-Earth Object Studies, CNEOS, and the Jet Propulsion Laboratory, JPL, were all over it, feeding data into their Sentry Risk Table. The European Space Agency chipped in too, double-checking the math. Everyone wanted to know, is this thing really coming for us? Here's where it gets interesting. That 3.1% peak didn't last long. By February 24th, 2025, just a week later, more telescope time slashed the odds to 0.004%. That's 1 in 25,000. What changed? Better data. Every new sighting refined its path, shrinking the error ellipse, the zone where it might end up. Turns out, 2024 YR4's orbit isn't as Earth-hugging as it first seemed. It's still a near-Earth asteroid, but the chances of it hitting us are now so tiny, you'd have better luck winning the lottery twice. Who's watching all this? A whole crew. NASA, ESA, the International Asteroid Warning Network, IAWN, even the Space Mission Planning Advisory Group, SMPAG. They track these rocks like hawks, updating the public through sites like NASA's planetary defense pages. Back in January, the buzz was loud. Some folks even panicked, thinking 2032 was doomsday. But by March 1st, 2025, the vibes shifted. Scientists are breathing easier, and the risk's practically a footnote. Does that mean we're totally safe? Well, 0.004% isn't zero, and there's a slim chance it could clip the moon instead, 1.7% to be exact. But for Earth, the roller coaster's coasting downhill. It's a classic case of how science works. Early guesses spark alarm, then precision dials it back. Remember Apophis in 2004? Same deal. Big scare, then nothing. Ever think about what had happened if those odds hadn't dropped? Let's paint that picture next. Impact Day. What could happen? Should asteroid 2024 YR4 defy its current low-probability trajectory and strike Earth on December 22, 2032, the consequences would hinge on its size and entry dynamics. Estimated between 40 and 90 meters in diameter, with a refined figure of 55 meters, this object's potential impact energy is calculated at approximately 7.7 megatons of TNT, assuming a velocity of 12 to 15 kilometers per second upon atmospheric entry. Such an event would not rival the global devastation of the Chicxulub impactor, but its regional effects could be significant, varying by size and impact location. If 2024 YR4 measures closer to 40 to 60 meters, it would likely detonate as an airburst, similar to the Tunguska event of 1908. In that scenario, the asteroid would fragment high in the atmosphere, releasing its energy in a massive explosion. The blast could flatten forests or shatter windows across an area spanning up to 2,000 square kilometers, depending on altitude and atmospheric conditions. Structural damage would be widespread. Imagine concrete buildings cracked and wooden structures leveled. But fatalities would depend heavily on population density beneath the detonation. An airburst over a rural region might cause minimal loss of life, whereas one above a city could injure thousands through collapsing infrastructure and flying debris. Should the asteroid reach 90 meters, its greater mass might allow it to penetrate deeper, potentially striking the ground. A surface impact would excavate a crater roughly 1 to 2 kilometers wide, hurling dust and molten rock into the air. The immediate blast zone could obliterate a city-sized area, with shock waves radiating outward, toppling buildings and igniting fires. Energy release at this scale, potentially exceeding 10 megatons, would rival small nuclear detonations, though confined to a regional scope. Secondary effects, such as seismic tremors, could further destabilize nearby areas, though global seismic activity would remain negligible. An ocean strike introduces another variable. Early projections place the asteroid's potential path over the Pacific, among other regions. While a 55-meter object lacks the mass to trigger catastrophic tsunamis, unlike kilometer-scale impactors, its impact could generate localized waves, perhaps tens of meters high near the strike zone. Coastal communities within a few hundred kilometers might face flooding, though dissipation over distance would limit broader oceanic disruption. The asteroid's relatively small size ensures no climate-altering dust clouds or prolonged cooling, as seen with larger historical impacts. The nature of destruction hinges on variables like entry angle and composition. A steep trajectory increases the likelihood of a ground strike, amplifying localized damage, while a shallow angle favors an airburst, spreading energy over a wider area. As a probable silicate-rich body, 2024 YR4 would fragment more readily than a metallic asteroid, influencing whether it explodes aloft or reaches the surface intact. Regardless, its effects would remain regional. No mass extinctions or global winters here, just a stark reminder of Earth's vulnerability to cosmic visitors. Initial risk assessments, though now diminished, highlighted this date, December 22, 2032, as a moment of concern. While current data suggests a near miss, visualizing such an impact underscores the stakes of planetary defense. Which regions once stood in its shadow? That question merits exploration next. The potential consequences of an impact raise a critical point. Who was at risk when the odds were higher? Examining the early projections reveals the geographic scope of this fleeting threat. Countries in the early crosshairs. When asteroid 2024 YR4 first emerged as a potential hazard in January 2025, its uncertain orbit traced a preliminary risk corridor across multiple continents. This path, calculated from initial observations, spanned northern South America, the Pacific Ocean, southern Asia, and parts of Africa. Specific nations identified in early models included Venezuela, Colombia, and Ecuador in the Americas, India, Pakistan, and Bangladesh in Asia, and Ethiopia and Nigeria in Africa. These projections, based on data before February 24, 2025, outlined a broad swath where an impact might occur if the asteroid's trajectory aligned with Earth's position on December 22, 2032. In South America, the corridor crossed dense jungles and urban centers alike. Venezuela's northern coast, including cities like Caracas, fell within this zone, as did Colombia's Andean highlands and Ecuador's coastal plains. An airburst or ground strike here could disrupt agriculture, infrastructure, and populations, though the region's varied terrain might limit blast propagation. Across the Pacific, the path extended toward Asia, where India's vast population density, over 1.4 billion, elevated the stakes. Cities like Mumbai or Delhi, if struck, would face catastrophic losses, even from a mid-sized airburst. Pakistan and Bangladesh, neighbors to India, also lay along this early trajectory. Pakistan's rugged northwest and Bangladesh's low-lying deltas presented distinct vulnerabilities. Mountainous areas might absorb some shock, while flat floodplains could amplify wave effects from an oceanic impact. In Africa, Ethiopia's highlands and Nigeria's bustling urban hubs, such as Lagos, rounded out the list. Nigeria's coastal proximity heightened concerns about localized flooding, though the asteroid's size constrained such risks. These projections fueled urgency in early 2025, when the collision probability peaked at 3.1%. Governments and scientists monitored the situation, aware that even a small chance warranted attention. However, as additional observations refined the orbit by late February, the risk corridor dissolved. The current 0.004% probability effectively removes these nations from danger, aligning the asteroid's path away from Earth. No specific preparations were enacted, given the brief window of concern and rapid de-escalation. This episode highlights the global reach of near-Earth object threats, even when short-lived. How does it compare to past events? Historical precedents offer valuable context. With the countries once at risk now safe, one might ask, what can history teach us about such events? Past impacts provide a lens to gauge 2024 YR4's potential legacy. Learning from history's cosmic smashes. Asteroid 2024 YR4's brief moment as a threat invites comparison to documented impacts, illuminating its place in Earth's cosmic timeline. The Tunguska event of June 30, 1908, stands as a close parallel. A 50 to 60-meter object, similar to 2024 YR4's estimated size, exploded over Siberia, releasing 3 to 5 megatons of energy as an airburst. It leveled 2,150 square kilometers of forest, snapping trees like matchsticks, yet caused no recorded deaths due to the region's remoteness. Had it struck a populated area, the toll would have been severe. mirroring the regional devastation 2024 YR4 might inflict. Contrast this with the Chicxulub impact 66 million years ago, when a 10 to 15 kilometer asteroid slammed into the Yucatan Peninsula. Its 100 million megaton blast triggered global wildfires, tsunamis, and a dust-driven impact winter, driving the extinction of 75% of Earth's species, including dinosaurs. Against this benchmark, 2024 YR4's 7.7 megaton potential is minuscule, no threat to planetary ecosystems or climate stability. Its scale aligns with smaller, more frequent events rather than apocalyptic collisions. Statistically, asteroids of 50 to 90 meters strike Earth every 500 to 10,000 years, based on crater records and NEO population models. The 2013 Chelyabinsk meteor, a 20-meter object, offers a modern example. Exploding over Russia with 0.5 megatons, it injured over 1,500 people via shattered glass and shock waves, despite its smaller size. Scaling up to 2024 YR4's dimensions, the damage radius and energy dwarf Chelyabinsk's, though still confined regionally. These incidents underscore a pattern. Mid-sized asteroids pose localized risks, manageable yet disruptive. Historical data also informs detection gaps. Tunguska arrived unannounced. Early 20th century technology couldn't track it. Today's systems like Atlas caught 2024 YR4 with years to spare, reflecting progress in planetary defense. Yet, the frequency of such objects, thousands orbit near Earth, suggests others may lurk undetected. While 2024 YR4's threat has faded, its predecessors remind us of the stakes when preparation lags. These lessons frame 2024 YR4 as a typical mid-sized NEO, potent but not world-ending. How do we ensure it stays a near miss? Current monitoring efforts hold the answer. History shows what's possible, but how do we stay ahead of 2024 YR4 today? Tracking its every move reveals the tools keeping Earth secure, how we're keeping an eye on it. Monitoring asteroid 2024 YR4 is a global endeavor, spearheaded by NASA's Center for Near-Earth Object Studies, CNEOS, and supported by a network of observatories. Since its detection on December 27, 2024, by the Atlas telescope in Chile, continuous observations have refined its orbit, slashing the collision probability from 3.1% to 0.004% by February 24, 2025. This precision stems from a coordinated effort involving the Jet Propulsion Laboratory, JPL, the European Space Agency, ESA, and the International Asteroid Warning Network, IAWN, which share data to map its trajectory. The process relies on optical telescopes capturing light reflected from the asteroid, paired with radar when feasible. Each observation narrows the uncertainty of its path, projected years ahead to December 22, 2032. The Sentry Risk Table, maintained by CNEOS, logs these updates, offering a public window into the asteroid's status. As of March 1, 2025, its risk is negligible, but monitoring persists to confirm this trend. A key milestone looms in March 2025, when the James Webb Space Telescope, JWST, will observe 2024 YR4. Its infrared capabilities will sharpen estimates of size and albedo, potentially resolving whether it's 40 or 90 meters wide. This data could further exclude impact scenarios or, less likely, adjust the odds. Ground-based telescopes, like those in Hawaii and Chile, complement JWST, ensuring no gaps in coverage. The Space Mission Planning Advisory Group, SMPAG, also plays a role, assessing response options, though none are currently needed. This layered approach, detection, tracking, analysis, mirrors strategies honed on other NEOs, such as 99,942 Apophis, whose risk was similarly downgraded with time. The system's success lies in its redundancy. Multiple agencies cross-check findings, minimizing errors. Beyond Earth, a lunar impact remains a slim possibility, 1.7% chance, which JWST data might clarify. Such an event would yield a 2-kilometer crater, spectacular yet harmless to us. For now, 2024 YR4's path suggests a safe flyby, a conclusion owed to relentless vigilance. Could we intervene if needed? That capability is next in focus. Knowing where 2024 YR4 is headed is one thing, but what if the odds turn against us? Exploring deflection options shows how humanity might nudge fate. Could we stop it? If asteroid 2024 YR4's trajectory shifted toward Earth, mitigation technologies exist to alter its course. NASA's Double Asteroid Redirection Test, DART, launched in 2021 and tested in 2022, demonstrated the kinetic impactor method. By crashing a spacecraft into the moonlet Dimorphos, DART shortened its orbit around asteroid Didymos by 32 minutes, proving a small nudge can redirect an object. Applied to 2024 YR4, a similar mission could adjust its path, given years of lead time before December 22, 2032. The concept is straightforward. A spacecraft, weighing mere hundreds of kilograms, strikes the asteroid at high speed, around 6 kilometers per second. For a 55-meter, multi-ton object like 2024 YR4, this imparts enough momentum to shift its trajectory by a fraction of a degree. Over years, that small change translates to missing Earth by thousands of kilometers. Timing is critical. Launching a decade in advance maximizes effectiveness, leveraging orbital dynamics. Alternative methods, such as gravity tractors or nuclear deflection, remain theoretical but viable. A gravity tractor, a spacecraft hovering near the asteroid, uses mutual gravitational pull to tow it off course, a slow but precise option. Nuclear blasts, detonated near the surface, could vaporize material, pushing the asteroid via recoil, though this risks fragmentation. Given 2024 YR4's current 0.004% impact odds, no mission is planned, but DART's success confirms readiness. Challenges include cost, international coordination, and the asteroid's spin, 19.5 minutes per rotation, which complicates targeting. Still, with monitoring ongoing and years to prepare, deflection is feasible if warranted. This capacity marks a shift from passive observation to active defense, ensuring threats like 2024 YR4 can be managed.